All right, let's take a look at section 3.4. So what I'm basically doing, I'm looking, and you might want to look too, right? You might want to have your book open. And Mia, where's your book?
Right here.
Is it? Oh.
Can I borrow a book?
Why do I have one up there with your name on it?
Actually, has it been there the whole time?
I don't know. Somebody put it on my desk over the break. I came in today and it was on my desk.
Does he need one?
So, well, don't keep it then. Make sure we put it back. Okay.
So now I don't have to pay for it?
Correct. So I don't know who turned it in. It just showed up on my desk. So. All right, let's take a look at the problems from 3.4. It's been a while, so I got to remind myself what's on here. So inequalities, solve each system of inequalities graphically. Yeah, so this shouldn't be too hard. I'm looking at 126. So let's do one of those. Let's look at number 5. Again, I haven't made it up, so maybe some of the ones we do today I'll put on the quiz. Maybe. All right, that's a weird 5, but that's a 5. So what is it? Y is greater than or equal to 3x minus 2. And y is greater than negative 2x plus 1. Let me just see something real quick here. Yeah. So it says solve each system of inequalities graphically. So am I going to get like a number like x is 3, y is 2? Is that what's going to happen? Do you remember? It's shaded, right. It's the stuff that's shaded because of what? What it indicated to you, the shading part. Yeah, the inequality. So let me get a graph here. So if I ask you to graph something, or if you need to graph it, like on this one, I will give you a graph on the quiz so that you don't have to draw your lines and all that kind of stuff. All right, so I'll give you something that looks like this. And so now we graph them. And it's set up, it's the first one, right, of this section, basically. So it's set up for you already. You hardly have to do any work to graph it. So let's do this. First, the first one is greater than or equal to. So what kind of line is it going to be? Solid line, okay? So 3x minus 2, that's easy. So we just put negative 2 right here. 1, 2, 3. 1 right there. So it is a solid line, so I can use that whole entire line right there. And right there. All right, so that's a little less than half of what we have to do. All right, what about this one? What kind of line is this going to be? It's going to be dotted because there's no or equal to. So we graph the line as if it was an equal. All right, we'll do the shading at the very end. Okay, we'll put the two lines first, and then we'll worry about what's shaded. Negative 2x plus 1, so I tell you what, let's do different color.
Yellow. I've never done
yellow. I have done yellow. So plus 1, and then negative 2 is my slope, so I go down 2, and to the right 1, right there. If I wanted to stretch it out, right, I could do that. Go down 2, go over 1, like that. Anybody see why I'm doing that? Why would I put those extra points on there? Because, yeah, just make sure it lines up, yeah. Okay? All right, that's not too bad. And let's figure out, let's do this in a different color. We'll go purple. Where's a good purple? Right there, that's a good purple. All right, so it says y is greater than the red one. So which way is greater than? Is it this way or is it this way? It's above, so really it's kind of what? I mean, this is getting close to vertical, isn't it?
Yeah.
So it's really everything to the what? To the left. All right? Everybody got that? So it's basically everything to the left of the red. So I'm shading in all of that. But just to kind of keep it nice and neat, all right, I'm just visualizing everything to the left of that red line being shaded, right? Or above, if you want to think of it as above the line. Yes? Okay, what about, oh, by the way, sorry, the blue one's supposed to be dotted. I'd do it a solid line, but you make it dotted, okay? I just don't have a dotted thing here. So let's do this one. What about this one? Greater than the blue one. So where's greater than the blue one? It's up. So it would be kind of like this way. So it's everything shaded to the left of the red one and everything shaded to the right of the blue one. So where do they mix? Just that V part right there. So we'll go a little thicker. So this is where you're going to shade it. So all of this, all right, it doesn't have to be beautiful, but I just got to know what you're talking about, okay? So that's your shaded part right there. So that's your answer right there. The graph is your answer, and the shaded part is your answer. Again, make the blue dotted. Other than that, that looks good. But it wasn't the combination. I think it was just one of them, right? You had that on a quiz before, probably. 1 to 4, I'm not going to put that. It's just 1 to 4 is too easy. All you got to do is just plug those numbers in for X and Y and see which ones work. I don't know. Let's do one of those. I may put it on the quiz. Again, I haven't made it yet, so it's a possibility I'll put that on the quiz. But this is over 3 sections, so I shouldn't have an issue with having enough problems. Because sometimes I do. Sometimes, like, how do I put 10 problems on a quiz when there's only 2 sections? You know what I mean? But on this one, it should be fine. I don't know. Which one you want to do? 3? I was looking at 3. So they give you a point, 2, 3, and they say determine whether the given ordered pair is a solution, and then they give you an inequality. So here's the first inequality they give you. Negative 2x plus 6y less than or equal to 14. All right, and then negative 2x minus y, negative 2x minus y, it's not equals, what is it? It's greater than negative 7. Okay? So I could give you something like this. What do you want to do? You just want to take that x and y, stick it in here, and see if it's a valid statement, right? If the left side is less than or equal to what? 14. Well, let's give it a shot. So what are we going to do? What are we going to put in for x? A 2, right? So I go negative 2 times 2 plus 6 times y, which is 3. Let's figure that out. That's negative 4. That's 18. What is that? That's 14, correct? Is 14 less than or equal to 14? Yeah. Okay, it is equal to. So that part of it is okay. But both of these have to be true, all right? So far, so good. So we got half of it. Now let's put this into the second one and see if that's true. So what do we do? Negative 2 times what? 2 minus y, which is 3. Let's see, is that greater than negative 7? I like to put it, I should have done it over here, but let's put a little question mark. I'm not really sure. All right, so what's this? Negative 4, let's do this in our head. That's negative 4 minus 3 is negative 7. Is negative 7 greater than negative 7? No, it's not. So is this a solution to both of these? No, it's a solution to one of them, but it's not a solution to the entire system, is what they ask for each system. It's not a solution, so you would just say what? No, and that would be your answer. But you got to do a little work to get the no. You can't just write down no and nothing else. If you do that, I'm not giving you credit for it. I'm just marking it wrong. Everybody understand that? Yeah. Makes sense, doesn't it? Oh, I am plugged up. Okay. All right. Enough of that. What about the next little section? It's really the same things we did with number 5. They're just maybe a little bit more difficult. Let's do one with an absolute value so we can remember that a little bit. 21. All right, let's do that one. I'll tell you what, let me do this first. Let me copy that. Oops. Put that here just so that I have it. All right, so 21, what's it say to do? Y is greater than or equal to x plus 2. And again, we're solving for these things, but again, our answer is not just going to be numbers. What's it going to be? It's going to be shaded stuff, right? Okay. So this is number 21 from section 3, what, 4? Okay. So how do I graph this? This one right here. First of all, what's an absolute value look like in general? It's just a V, right? What is that plus 2? I think we talked about that in here, didn't we? Yeah, it means it goes to the left too. So instead of starting here at 0, 0, let's change colors. You want yellow? You got yellow. All right, we'll do the other one in pink. All right, so this starts right here. Everybody see that? Even though it's a plus 2, when it's inside the absolute value, that means you go in the other direction. All right? So this actually goes to the left 2 places. It starts right here. So what's the rest of the graph look like? Yeah, just go up 1, right? Just like this, like this. And then it's the same thing on the other side. Everybody good? It is greater than or equal to, so what kind of line? Solid line. I'll probably put solid lines for both of them just because I can't figure out how to do dotted lines on here. I know there's a way. I keep saying that all the time, and I never do any research. All right, so that's what that looks like right there. Now, it says greater than or equal to. The or equal to means it's solid. What does the greater than mean? Everything's shaded where? In between, okay? All right, inside of it. That would be greater than. I'm just looking. Oh, wow. Okay, let's do this in a different color, pink. All right, what does this mean? This minus 2 is outside of the absolute value. So this doesn't move it left or right, it moves it down, right? When it's outside of it, it moves it up or down. This does go the direction you think it should go, all right? It does go down 2 places. So instead of starting here, it starts right here, okay? And then, again, there's nothing in front of it, so you just up 1, over 1, right? You can keep going that way, that one, and it keeps going that way. This should be a dotted line, all right, but I'm not doing it, but you do it if you have to on the quiz. Oh, it goes right along there, doesn't it?
Look at that.
Okay. Now, it says less than. Okay. Yeah, we're good. So, all right, it's got to satisfy both of these things. Let's go to that purple again. So it's got to be greater than the pink one. So it's everything. I'm sorry, this was yellow, wasn't it? Everything inside the yellow, right here, and then everything outside the pink. So it's everything but this little rectangular looking part, okay? So it's all shaded here. Whoops, what do I just do? I know what I did. Let's do that. There we go. Let's try this again. All right, so it's everything shaded here. That's greater than the first one and everything less than this. So everything's shaded like this. All right, might be able to shade a little bit better with a pencil than I can with this thing. All right, but that's what it is. So it's everything but this little part right here that goes off like that. So that's your answer. That shaded part, that graph and the shading is your answer. And again, like I said earlier, the pink one should be dotted as long as you're good with that. Okay? Now, how far does the dotted really have to go? It only has to go dotted up to there because this one's going to be solid because of the yellow one. So this could be solid from here on out. It's just here to here is dotted, and then here all the way out there is dotted. Okay? All right, so section 3-4, that wasn't hard at all, was it? All right? Yeah. What's that?
Who made the rules of math?
I did. So obey them. Obey my rules. All right. 3-5. Let's see how I'm going to give you this because we got to do a little bit of this. I'm not going to give you the word problem, though. Remember we did word problems with this? Okay, because that would take way too long, especially for a quiz. There's no way I'm going to give you that for a quiz. So let's do...
What are you going to give us?
13.
yeah, let's do something like that. That's a good idea.
Honor.
So now we're on section 3.5, okay? And I'm looking at, 3.5. I'm looking at page 131 and number 13.
Are we gonna have to are you gonna give us a graph or are we gonna have to graph?
I'll give you a graph. Yeah. This thing right here? Is that what you mean? Yeah. I'll give you this. I'll give you a graph. So you don't have to draw it yourself. I'll give it to you, okay? And let's see. 13. It says maximize. This is a lot easier than it looks. It looks daunting. It's not as hard as it looks. Really, if you can do what we just finished doing, that's basically, and then there's just one little extra part, right? It's actually kind of like a combination. So it's kind of a combination of the two things we've done already in one problem. So really, it shouldn't be any different than what we've done already. So it's x is greater than or equal to 0. And it's y is greater than or equal to 0. You got two more. X plus, can I fit them in here? X plus 3y is less than or equal to 15. Nice thing about this, I can just move it over. And then one more. What is it? X plus y is less than or equal to 7. Okay? These are all or equals, so we're good with solid lines. I tell you what, I am not going to color code them. I'll just do one color. We'll do them all in the same color. So x is greater than or equal to 0. What kind of line is that? It goes through the x-axis at 0, so it's basically a vertical line. It's basically the y-axis, isn't it? What about this? Y is greater than or equal to 0, so it goes through the y-axis, and that's a horizontal line. Okay? Now, right here, we just have to solve for y. So let's do that. So 3y, I'll just put equals. Even though it's less than or equal to, we'll do the less than just determines the shading. I just want to figure out where my line goes, okay? So I'll just put equal. Is that everybody okay with that? Negative x plus 15. Divide by 3. Divide by 3. So what is this? Y is equal to negative 1/3 x plus 5. So let's graph that. So 1, 2, 3, 4, 5. The slope is negative 1/3, so I'm going to go down 1 and to the right 3. Did I go 3? 1, 2, 3. There we go. Down 1 to the right 3. 1, 2, 3. All right, and then I'm going to graph that.
That's a nice blue. I like that blue.
It is a nice blue.
Do you like the blue?
What do you think it's called? Blue's my favorite
Blue.
That's not.
All right, what about this one? This is easy. Just subtract the x from both sides. Again, I'm just going to draw the line, so I'll put it equals. So negative x plus 7. So 1, 2, 3, 4, 5, 6, 7. Right there. The slope is negative 1. I'll tell you what, I'm going to go down. I want 7, right? So I'm going to go down 7 to the right 7. It's still negative 1, isn't it? But I think I can be a little bit more accurate if I stretch it out a little bit. So that's what I did there. Alrighty. So now, where's the shaded part going to go? Well, it's greater than the axes, right? So it means it goes to the right of the x-axis and it goes above the y-axis. So I'm just confined to the first quadrant. That's what these two do, okay? What does this one do? This is less than, and which one was that? That was this one right here. This is where the colors would be nice, but anyway, it's this one right here. So it's less than, so that means it's everything down here, all right? And it's less than the other one, right? The 7. So where is the shading? It's just this. Oops, one above it. So it's below this. Let's see. It's below that one, and it's below that one, which means it's just this stuff. Do you agree? All right, so that's the shaded part. What are we really concerned about, though? To maximize it, what do we want to find? The ordered pairs, right? So we want to find that number, and that one. Okay, you with me on that? Because that's the part that's shaded. These are the vertices that make up that shaded region. Okay, and so let's list them out. So first one is 0, 0. This top one is 0 what? Is that 5? And this one is what? 7, 0?
Wait, you need to do that?
Yeah. Because you got to find the maximum. And then what's this one right here going to be? That's the hardest one. 1, 2, 3. 1, 2, 3, 4. So 3, 4.
I'm saying like on the graph you have to label them.
You don't have to label them, no. But I'm doing them here because I need to put those numbers into.
No, I know that. I'm just asking like on the graph. Like
No, you don't. I answered it. So we're putting it into this.
If we have like different colored pens, can we use them to make it easier?
Sure, I don't mind. All right, here we go. Put 0, 0 in for this. So what's that going to be? 0. Put a 0, 5 in for this. So that's 0. 5 times 5 is 25. Put 7, 0. So 2 times 7 is 14 plus 0 is 14. And then put a 3, 4 in this. 2 times 3 is 6. Plus 5 times 4 is 20. And that's 26. So what's the maximum? Yeah. Actually, I think the maximum is 26 at the 0.34. I think that's kind of how they write the answer. Yeah, they do this. They put, I would do them both. Okay, show me the point and show me what the maximum number actually is. Okay, so show me both of those. I mean, they're gonna be next to each other anyway, right? Depending on how you do it. So you might as well just do it like this. This is what how the book writes it. F of 3, 4 equals 26. So this is how the book writes it. I'm fine just writing it like this. No big deal. But that's how the book does it. Okay, we good with that? So from section 3.5, that's all I'm going to ask you to do. All right, I'm not going to do that long word problem. Remember that with the surfboards or whatever they were. What were they, skateboards or something? I don't know what they were. So don't worry about that. I just want to do that problem just to show you like what the purpose of this is, right? Or what it could be, right? And that's all we wanted to do there. All right, so that's all I want you to do for that one. All right, let's move to 3.6, and then that should cover the whole quiz. On 3.6?
No,
On 3.5? 21? No. Because I'm going to give you something more like this. That one's too complicated. I'm not going to give you a real complicated one. Okay, I'll give you one that's pretty simple. All right, 3.6. So what do you have to do for this one? Oh, okay. Might give you a couple of these. This is where you had to solve for x, y, and z. Remember that? So give me one. Let's do an easy one first. Well, what should be kind of easy, maybe. 10? All right, let's do 10. So this one, there's no graphing. It's just all algebra. X plus y minus z. This takes forever to write. Equals -4. And then 2x plus 5y, 2x plus 5y plus z equals 25. You can do it however you want to do it. X minus 2y minus z equals -16. All right, and it says to solve, basically. Just solve for x, y, and z. Just. Yeah, I would probably eliminate the z's. I think that's definitely the easiest way on this problem. This is probably one of the easier ones. In my mind right now, I'm thinking of the quiz, putting it on the quiz up. I might give you two of them. Maybe I'll give you one that's super easy, right, where you can eliminate super quick, and then another one where you might have to think a little bit. All right, this one you don't have to think too much. So yeah, that's what I would do. I would take these two. And let's put it up here. Yeah, and just eliminate the first two. So they go. So bring everything else down. What do I get? 3x plus 6y equals, what's that, 21? If you wanted to, that'd be all right. That's probably what I would do. Look, yeah, 3 goes into everything there. So just to make the numbers a little smaller, easier to deal with, you don't have to do it, but you can. So what's that going to be? X plus 2y equals 7. All right. So I'm going to put that in a little box. We'll hang on to it. You could do it right now if you wanted to. Let's do that. I was thinking of, well, you could, but then you still need to, I wouldn't do that just yet. Let's put it back in the box. I mean, you could get it, but you're not really getting an answer. You're going to have to substitute it back in anyway. So I think, personally, just taking these two, I'll tell you what, let's move this over here. I would just do this again. I mean, you could do that. I mean, you're not wrong by getting x by itself and then plugging it back into something else, but I don't know. I just think this might possibly be a little easier. So now I'm taking what? The second one and the third one, right? And I'm basically doing the same thing. So this is going to be 3x. This is going to be plus 3y. And this is going to be, what's that, 9? Yep. Is that right? Divide everything by 3. X plus y equals 3. All right. And then you can do whatever you want at this point. Well, not whatever you want, but you could put them together and do elimination again. Or if you wanted to, you could solve for x and put that in for the other one and you get y. Then once you get that, I think either way would be just as easy. You want to do the substitution or the elimination? Okay, so I'll just write it out. Now, what are you going to do here? These are both positive, right? So just make them negative. Okay? And then cancel. What do you get here? Y equals 4. All right? That's one answer. I probably shouldn't really circle it because we want to circle the ordered triple. Remember that? So y is 4. Let's solve for x. Let's put the y right here. So x plus 4 equals 3. Subtract 4 from both sides. So x is -1. And then let's solve for z. Probably the first one's the easiest one. So x is -1 plus y is 4 minus z equals -4. That's a 3. Subtract a 3, correct? Negative z equals -7. Z equals 7. And then you write it all together as an ordered triple. The x goes first, the y goes next, and the z goes last. And that is the one you're going to circle right there. You okay with that? That was an easy one. I'll give you an easy one. It may be this one, it may not be this one, but I'll give you one that's pretty easy. All right, and do we have time? Yeah, we got 10 minutes, right?
No, 5.
5 minutes? Oh, the next class is 10 after, right? Or no? What's the? Oh, the next class is the last class, right? Oh, I was thinking I had 2 more. Oh, good. Yeah, that is nice. when you think you have more. All right, so anyway, I still got 5 minutes. You want to do one? No? All right. Yeah, see, then you should say yeah. What is that? Oh, the graphing? Oh. CUDA. Kuta. Let's see. Yeah, Kuta. Software, then .com. All right. All right, we good? Which one you want to do? All right, let's flip the page. Look at page 138. I'm not going to give you one that comes out to fractions or anything like that, or decimals. I'll keep it easy for you. Let's do, I don't know, 24. Is that all right? All right. X plus 2y minus 3z. X plus 2y minus 3z equals, oh, that's a decimal one. Let's not do that one. 21, that comes out to decimal or fractions for an answer. Let's just do 20. X plus 2y plus z. X plus 2y plus z equals 8. And then y minus 3z equals 9. And this one's a little easy, but they tell you z already. All right, they made this too easy. They didn't? Yeah, they did. All right, so where are you going to put that? I'm definitely going to put that -2 somewhere. Which one? You're going to put it in the top one? Nah, put it in the second one, right? So it's going to be y minus 3 times z, which is -2. That equals 9. So that's plus 6, right? Subtract a 6. What's y? 3. So I got 2 already. I got this one, and I got this one, and now this is way too easy. And then I just solve for x. Yeah, you can do the rest. I don't need to do that, do I? All right, put it in there, solve for x, and that's 4, 3, -2. 4, 3, -2. I probably will not give you that one. Maybe like, you know what, I was looking at the wrong thing when I said 24. 24 is legit. 24 is, because I was looking at 26 for the numbers, even though I wrote down 24. So let's do that one. I don't know if we have enough time. Yeah, I'll just write it out. 5x plus 3y equals 17. 2x minus 4z equals 2. And then 3x plus y minus 5z equals 7. All right, so where would you go with this? You know what I would do? If it was me, I would take the second one right here, divide everything by 2, just to make it real easy, and then I get x by itself and then substitute x in. You see that? Doesn't mean it's the only way to do it, but it's the way that I see to do it. So I divide everything by 2. So what do you get? X minus 2z equals 1. See what I did? Divide everything by 2. Now I get x by itself. So x equals 2z plus 1. Now I can take that and put it in where? I'd probably put it in for this one, wouldn't you? Right there. So then I would go 5 times 2z plus 1. You know what? I don't know if I'd go that route. Yeah, I guess it's really the only... Yeah, that's fine. 2z plus 1 plus 3y equals 17. So that's 10z plus, what, 5 plus 3y equals 17. Let's just get the x's and y's together. You got an x and y here. I guess. Let's just do it like this. 10z plus 3y equals 12. How did I get that? Subtracted a 5 from both sides. So I got a y and a z here, right? I got x here. I could do this. Watch. I could take this again and put it right there. And then I got y's and z's. Everybody see that? Then I'll have y's and z's, and then you're going to take this one, combine it with the y's and z's that you get here, and then the rest of that should be pretty easy. Okay? Does that help? All right.